Hi, this is Professor Delancey. Just want to go through those last set of homework problems with you. That's our first homework doing proofs. And to be honest, the homeworks were very mixed. I think a lot of you didn't really have a sense of how we use the rules. So I'll go through all of these problems very slowly and show you in each case exactly what's going on. So here's the first problem. It's pretty simple. There's a conditional. It says if Q is false, then S is true. And we have a premise, Q is false. I hope that if you hear that, if somebody were to come to you and say, it's not raining out, furthermore, if it's not raining out, then we can go to the movies, you would conclude, okay, we can go to the movies. And that's exactly what this inference says. We have these two rules. Whenever you see a conditional like this, you should be thinking, I have these two rules, modus ponens. And modus ponens is, remember, this form. And we have this other rule, I'll write it over here, modus tollens. And modus tollens is of this form. I have a conditional, and if I have the denial of the consequent, I can deny the antecedent. Remember, consequent and antecedent are the names for consequent, antecedent, the two parts of a conditional. Now I look at this conditional, let me grab my eraser. I look at this conditional, I should think, okay, whenever I have a conditional, I should be asking myself, can I do modus ponens? So you think like, I can put in not Q here, and for psi I can put in S. So that's an instance of modus ponens. Here's an instance of modus tollens. I'm going to put not Q in wherever there's a phi, and I'm going to put S in wherever there's a psi, and I have this instance of modus tollens. So whenever you see, conditional, you should be thinking, do I have the denial of the consequent of the right-hand side, or do I have the assertion of the antecedent of the left-hand side? And in fact, this, I hope you see, is just like this. The order is different, but we don't care about the order. And so wherever I have these two lines, the rule is I'm allowed to write down that line. So line 3, S, and I say modus ponens 2, 1. I use these two lines. The modus ponens rule requires two lines, only two lines. And it says if you have these two lines, you can write down this line. And that's exactly what you and I did. And that's what we were hoping to show. So that's how we solve, that's how we complete proof. The first proof, proof 1a. Let's take a look at the second proof, proof 1b. Okay, here's problem 1b. Here's problem 1b. And we have three premises. If S, then not Q. If P, then S. And it's not the case that not P. And we want to show not Q. Again, you see conditionals, and you should be thinking, can I do modus tollens? Do I have the denial of the second part? Do I have not S, or do I have not Q? I should also be looking at them and saying, do I have the assertion of the first part? Do I have S, or do I have P? So I can do modus ponens. We also have a double negation here. Remember, we have a double negation rule. I'll just write DN for it. And the double negation rule says that if you have two nots in front of a formula, anytime you want, you can write, you can sort of remove the two negations, or rather, we should really think of it as, if you've written down this, you're allowed to write down this. Similarly, we have a different version of the rule that says, if you've written down some formula, anytime you want, you can write down that formula with two nots in front of it. So two versions of the double negation rule. So looking at all that, hopefully you use what I call the flail method. Just try different instances of the rules and see if they help you. Whenever I see two nots, right, I'm thinking like this. Here's an instance of the double negation rule. If I erase phi and I put in here P, the rule says, and the double negation rule just uses one line. It says if anywhere you've written down this line, you're allowed to write down this line. So I could say P. That's not Q. I wanted to show not Q. But maybe it's going to be helpful to me, right? And I'll put this back into its general form now that we've made use of an instance of it so that we're able to refer back to it later if we want. And so now I'm looking at these formulas. What else can I do? Is there anything else I can do? Well, if I had S, I could do modus ponens. Or if I had P, I could do modus ponens, right? If you look over here at this rule, if I put in P for phi, and I put in S for psi, this is an instance of the modus ponens rule. Again, it says if you have written down P or OS, and you've written down P anytime you want to, you can write down S. So let's do that. Tell me where these two lines came from. And that's an instance of modus ponens. Of course, let's put it back in its original, in its general form. We might want to use it again. Or rather, we might want to use a different instance of it, I mean. Looking, I still want to show not Q. How am I going to show not Q? Well, I'm not sure. But I do notice at line 1, maybe I can make some use of line 1. Maybe it'll give me some interesting information. If I had the denial of not Q, I could do modus tollens. Or if I had S, I could do modus ponens. But I do have S on line 5. What was the instance of modus ponens I used? It was this instance, right? For psi, I put in not Q. For phi, I put in S. And this tells me if anywhere in your proof you've written down this and you've written down this, you may write down this. So we have written down S0 not Q. We have written down S on lines 1 and 5. So you can go ahead and write down not Q. That's an instance of modus ponens. And that's what we were hoping to show. We're done. Okay, problem 1C. We want to show not Q, and we have 4 premises this time, so it's a bit more complicated of a starting place for us. Premise 4 is a negation of P, and all the other premises are conditional. So I should be thinking, do I have the antecedent? Do I have T or Q or S? Then I could do modus ponens. And I should be thinking, do I have, to use the modus tollens rule, do I have not P or not S or not T? And in fact, I do have not P. Correct? So I can use, if you look at, if I put in T for phi, and I put in P for psi, I get this instance of the modus ponens rule. Excuse me, the modus tollens rule. And so we can apply that instance of the rule if we have this line, but we do have that line at line 1. And if we have written down this line, we have done so on line 4, then the modus tollens rule tells me, hey, anytime you want to, you can write down this, right? You can assert this, not T. And that's my justification, modus tollens lines 1 and 4. But I want to show not Q. I mean, is not T helpful to me? I don't know, right? I look around. Do I have not T arrow something and I can do modus ponens? No, I don't. Do I have something arrow not T? If we go back again to our modus tollens rule, right? If I have a conditional and I find out the second half is false and I know the first half is false, and I do have that, right? Right here, line 3, it says S arrow T. And so I can say not S. Still, that's not Q. I want to show not Q. What else can I do? Well, you know, looking around at what I've got here. Excuse me, yeah, I got that right, sorry. Looking around at what I've got, you know, I don't have not S arrow anything, so I can't do modus ponens. But I do have this formula Q arrow S. So if we go back to the general form of our rule, maybe you and I can see it without having to fill it in now. If I have a conditional, like I do here, and I know the second part is false, like I've asserted on line 6, then I can say the first part isn't true. Modus tollens 2, 6, right? Here's line 2. Here's line 6, the denial of the, what we call the consequent. So we write down the denial of the antecedent. That's what we were trying to show. Good, right? Let's try the next one. Okay, here's problem D in our set of problems. And we had three premises, and we're trying to prove Q. Now looking at this, I have these two atomic sentences. You know, there's not a lot I can do with atomic sentences. I could do double negation, this version of double negation, and put two knots in front of them. I don't know about you, but I don't see how that could help me get any closer to Q. But I have this conditional, line 3. And again, always you see a conditional, you should be thinking, do I have the first part so I can do modus ponens? Or do I have the second part so I can do modus tollens over here? Let's look at the instance of the rule. We'll go ahead and put in P for phi. Right? And I'm going to go ahead and put in this part, R arrow Q for psi. And that's an instance of modus ponens. And in fact, you and I are ready to do that, right? We have on line 3, we have this conditional. And on line 2, we have the antecedent of the conditional. So again, when you've written down this and this, the rule tells me I can write down this. Modus ponens is my justification. Well, that was interesting, but I want to get to if R is true. I want to show Q, and what I've gotten to is if R is true, then Q is true. But note that R is true. So again, that should be making you think that, again, we're seeing an instance of modus ponens, right? That's an instance of modus ponens. And I've got that. I have this on line 4. I have this on line 1. And so modus ponens tells me Q. We're done. Okay, this is E. So this is E in our homeworks. This proof makes a very simple point. It makes the point that conditionals can be complex, and they're still just conditionals, right? They still just have the if part and the then part. And if you're doing modus ponens or modus tollens, you have to sort of be able to see what the part is. So I have this complicated conditional if R implies S, then Q. I have this other one, if it's not the case that R implies S, then V. And I have this negation sentence, not Q. I hope that looking at these, you're sort of thinking, okay, if I had this, I could do modus ponens, or if I had this, I could do modus ponens. If I had not V, I could do modus tollens, or if I had not Q, I could do modus tollens, but I do have not Q. If you don't see it, go over here and put in Q for psi, and for phi, put in R arrow S. So that's an instance of modus tollens, right? And that's the instance of modus tollens that you and I are going to use. On line 1, I have this formula. On line 2, I have this formula. So here on line 4, I'm allowed to say it's not the case. R arrow S. And now, again, hopefully you're looking at that and you're thinking, you know, I could use line 1 again maybe, but let's see what else. We're trying to get to V. V's in this formula. If you look at this, well, when could I, you know, is there any sense in which I could know that V is true? Sure, if you knew this part was true. That would be an instance of modus ponens. If I knew that it's not the case at ROS, then I would know that if not ROS applies V, we should be able to assert V. So even though it's a bit complicated, that's still just an instance of modus ponens. So I'm going to say V. Oh, sorry, that was modus tollens, right? And now I'm going to do modus ponens. I'm going to say, hey, look, on line 3, I have this conditional. And on line 4, I have the antecedent. So modus ponens tells me V. And we've done it. That is the conclusion we were looking for. Once we get to the conclusion, we stop, right? Remember what the proof is saying. It's saying if this stuff is true, then that's true, then that's true. Okay, we just want to show our conclusion has to be true. Good, let's look at F. Here's problem F. Very simple point being made by problem F, just to say, hey, when you're doing modus tollens, the consequent of the conditional could be complicated. That's okay. So look over here. Sorry, I'm reaching for my eraser. imagine we look at this formula and I say, hey, I wonder if you, under what conditions you'd be able to do modus tollens on it. And if I put in P for phi, I get this. And if I put in Q arrow R for psi, I get this. So yeah, that's a complicated version, or instance, excuse me, of modus tollens, but it is an instance of modus tollens, and it's exactly what you and I have here. So we can say it's not the case of P, because on line 1, we have this conditional. On line 2, we have the denial of the consequent, the denial of the then part, and modus tollens tells me, therefore, not P. Pretty straightforward. Okay, we're almost done. Here is G. And in G, we have 3 premises, right? If it's not the case that Q implies R, then P. But it's not the case of P. And furthermore, Q. And what we want to do is show R. So again, when I look at Q, it's an atomic sentence, so there's not a lot I could do. Maybe I could do double negation and put 2 knots in front of it. I might do that later. Let's see if it's useful to me. When I look at not P, it's a negation sentence. Again, not a lot I can do. I just have a single negation, so I cannot use the double negation rule, which only takes away 2 knots, never 1. So let's look at this conditional. Well, I could do modus ponens if I had not Q arrow R as a premise, and then given that the consequent is P, I could conclude P. But I don't have that as a premise, right? I don't have that as a line anywhere. What else can I do with a conditional? You know, I could see, can I do modus tollens? So here again, I'd have the conditional. It's rather complex, right? But I'm going to write in there P for psi, and I'm going to write in not the case Q arrow R for psi, the pitchforky guy, right? And so that was really just copy and replace. And this is an instance of the modus tollens rule. Well, look, line 1, I do have this. Line 2, I do have this. So modus tollens tells me I get, it's not the case and it's not the case, the Q arrow R. Whenever I see something like that, I always think double negation. You know, let's get rid of those knots. They're sort of complex and they prevent me from using whatever's behind them. So I did double negation on line 4. Again, line 4 says if you've written down something in this form, you can write down something in that form. And now looking at that, I hope you see that on line 5, I have a conditional. On line 3, I say the if part is true. So I can say modus ponens are. And that's what we wanted to show. So that was the second to last problem. Let's see the last one. So here's our last problem, H. This one perplexed a lot of people. I'm not sure why. I didn't mean for it to be tricky by any means. One thing that Jeremiah pointed out to me is that in all my previous examples, we'd only used a line once, and so maybe people thought that I meant that as a sort of implicit rule, but it's not an implicit rule. It's not a rule of any kind in our system. If something's true, it's always true. So you can use P in a rule anytime, as many times as you like. So maybe that helps people who were a little confused by this. When I look at this, I got an atomic sentence. Not a lot I can do with atomic sentences. You know, I can use double negation and put 2 knots in front of them, but not much else. I have 2 conditionals. Always when I get the conditional, I'm always going to think, if I have the first part, you know, then I can assert the second part. Or if I had the denial of the second part, right, I can write down the denial of the first part, you know. This should be R, forgive me. So I don't have this situation, right? I do have this line, but nowhere do I have that line. I do have this situation. So I can say, hey, look at line 2 and look at line 1. I've asserted these two things, so anytime I want to, modus ponens says I can write down R. That's interesting. It's not what I was looking for. I was hoping to prove Q, so it looks like I'm going to have to keep working. What else can I do? Well, I got all these lines. You know, I can put two knots in front of P, or I can put two knots in front of R, but I don't see how that's going to help us. What else? What about line 3? Well, what else can I say about line 3? This also is an instance of modus ponens, right? That is an instance of modus ponens. And I should look at that and say, oh yeah, look. On line 3, I have this thing. On line 1, I have this thing. So modus ponens tells me anytime I want to, I can write down R arrow Q. Interesting, might be useful to me, but I wanted to find Q, so I'm not done yet. I won't be done until I find Q. I got a lot of things to work with here, but I don't know about you, but I'm, 4 and 5 are really sticking out to me. Again, I have modus ponens looks like this. Well, I should be looking for, hey, do I have this instance, can I use this instance of modus ponens? And in fact I can. I have line 5, R arrow Q, line 4, R, modus ponens, Q. There's the whole proof. All right, I hope that's helpful. Let me know if it is or isn't. And as I say, there was a lot of sort of weird use of rules, but really the rules really force us to just do exactly one thing, each rule. Modus ponens takes 2 lines, never 3, never 1. It spits out 1 line, right? Double negation takes 1 line, never 2, never 3, spits out 1 line. And we're finding those instances of modus ponens or double negation or modus tollens, or later simplification and adjunction that can help us solve our proof. Okay, good luck, thanks.